Okay, hey everyone. In this video we are going to do a continuation of a previous example where we use nodal analysis to solve for the voltages at three different nodes, illustrated here in this picture as V1, V2, and V3. So the last time we did this example, we did not use the fact that there was a supernode to our advantage. In this example we are. So there are two voltage sources in series. So this whole thing over here is actually a supernode. Everything that's inside of this yellow highlighting. What I'll do next is define the the directions of the current with respect to this one big node. I just have to be consistent with my directions. So if I say that current is going up here, meaning it's going from right to left across the 6 ohm resistor, it must be coming down and into V1 on the left side. So I have to be consistent. It's arbitrary as long as I'm consistent. So actually, let me change this up. So I could just I could just have easily done this. I could have said it goes downward on this side and it goes upward on that side. I'm consistent because with respect to this arrow here, it's saying current goes from left to right across the resistor. Same thing for this arrow down here. This is saying that current also goes from left to right, so I'm being consistent. And again, it's arbitrary, so you'll notice that with respect to about 30 seconds ago, I had these arrows flipped. Now I'll put in the directions for the rest of these, and I'll leave it like that. Again, it's arbitrary as long as you're consistent. And with respect to these guys, there's nothing to be consistent with, since it's a single branch and you only define the current once. Okay, so let's go ahead and write in our equation here for KCL. I'll just give these names real quick. I1, I2, I3, I4, I5. So going into this supernode is only one current, and that is I5. And then all the other currents are leaving the supernode. You can see all the other currents are facing away from the yellow. So let's write that in. I1 plus I2 plus I3 plus I4. Okay, and now what we know is we can, or what we always should do after we write the KCL expression in terms of currents, is translate it to voltages. So let's do that. I5 is here, and that's going to be V1 minus V3 over 6 ohms. So the current starts from V1. Think of the minus sign as an arrow, goes toward V3 through the 6 ohm resistor. So you divide by 6. Now you do that for the rest of these guys. So for I1 is actually going to be the exact same thing as I5, which we already knew. V1 minus V3 over 6 plus I2, which is going to be V1 over 2 plus I3, which is going to be V2 over 4 plus I4, which is going to be V3 over 3. Okay, and right off the bat, we can notice that these guys will zero each other out. So let's cross those out. Let's check how many unknowns we have. 1, 2, 3. So we have one equation, 3 unknowns, so we need 2 more equations. And we're going to get those 2 extra equations from these individual voltage sources that make up the supernode. So we'll do this guy first, this 25 volt source. What it's saying is that if you start from V2, as you move toward V1, you're going to experience a voltage gain of 25. So let's write that out as an expression. So V1 is going to be equal to V2 plus 25. Now we do the same thing for this other voltage source here. This is a dependent voltage source. The amplification is 5, and it depends on the current, specifically the current of I2. So to write that out, V3 is equal to V2 plus 5 times I2. So I'll write that out, and now I'll just sub in for I2. I2, I think we found, was V1 over 2. Yep, V1 divided by 2. And so let's scoot this guy down off to the side. We don't care about it. Delete this. Scoot this back up. And now let's tally things up. So now we have 3 equations and 3 unknowns. With these 2 new equations, we didn't introduce any new unknowns. So if we solve this now, there are only 3 equations to solve, and you can do that in MATLAB or Python, your favorite tool. And what you'll know or notice is that there are fewer equations here, so it'll be a more pleasant of an experience compared to what we had earlier when we didn't use the fact that there were supernodes here. There were supernodes here. Okay, and then the answer key is right here. The V1 answer should be 7.6. You can see it in the yellow here. V2 should be 17.39. There might be a negative sign in front of that. And then V3 is 1.63 volts. All right, thanks.